we present BlobGAN, a new mid-level representation for generating and parsing images of scenes. Most current work in generative modeling focuses on images of solitary centered objects, such as the one shown here. However, in our day-to-day lives, most of what we encounter looks much more like this image on the right, a complicated scene filled with different entities interacting with each other. Representing these complex images has been an active area of research for decades in computer vision. In most recent work, scenes are represented no differently than objects, whether in a bottom-up way, where each pixel has its own label, or top-down, where the entire image has a category. We focus on mid-level representations and propose a model where scenes are represented by spatial layouts of depth-layered blobs, and each blob corresponds to a different entity in the scene. We incorporate this blob representation into the architecture of a style-based generative adversarial network. Our model first generates a layout in the form of a blob map like the one shown here. This map is then used as input to a convolutional decoder, which outputs realistic images. Since blobs are spatially uniform and convolutional receptive field is limited, our model must generate an image region of self-similar appearance for each blob's location. The solution that emerges is for the model to associate blobs with different entities in a scene and to arrange these blobs to capture scene layout. For each blob, our layout network outputs both deep structure and style features, as well as spatial parameters, position, size, shape, and orientation. Features are differentiably splatted onto a depth-ordered grid, and then alpha composited back to front to yield the final blob map. Once our model is trained, we can edit images by making changes to the blob maps that yield them. We next show the wide variety of scene edits enabled by our model. Here, we move around all objects in the scene simultaneously by repositioning their blobs. We can do this for one object in isolation too. By resizing blobs, objects in the scene are shrunk or enlarged, and if the blob is made small enough, the object disappears. Copying and pasting blobs clones individual objects in the scene, generating images that did not appear in the training distribution, such as rooms with two side-by-side ceiling fans. We can also swap the style of only one object in a scene, while leaving the rest untouched. Here, we swap styles of beds, paintings, and windows. We also train our model on a dataset of multiple indoor scene categories. On this data, our model outperforms standard StyleGAN 2 on image quality as measured by FID. As before, images can be edited by manipulating the blobs underneath. Our model learns to associate one particular blob, shown in coral here, with all different kinds of tables across scene categories. Our model can be used to parse real images by reconstructing them in blob space. We can then perform the same set of edits as before by manipulating underlying blob maps. Finally, we can use our model to perform various conditional scene generation tasks, a functionality we call scene autocomplete. For example, given an empty room in the form of a background feature vector, our model can generate compatible arrangements and styles of objects to furnish the room. We can also generate different rooms with objects at user-specified size and location, as we show here. Thanks for watching. For more, please see dave.ml/blobgan.